Alright, so uh, today we'll be doing another question, that is search a 2D matrix. That's the second part of it. So what we have here is uh, the difference is that here we have sorted like according to rows and columns. So you can see all the rows and columns are sorted. So uh, like for me, I feel like the basic difference is that just a second. Hello. Yep. I feel like for me, the basic difference is that to how to notice it. So I feel like here you can see the row is sorted, like this column is sorted and this row is sorted. You will see this diagonal being sorted, but you won't see this diagonal being sorted in the right manner, like the ascending one. So this goes in descending order, but I feel like the one that is the first part of it, I guess that's having this also sorted in the right manner, the ascending one. Like the symmetry is maintained, I would say. Nothing is like sorted but in the opposite direction. But anyways, uh, we'll start with the same approach for it as we did in that case. uh, what we can do is first of all we can create uh, a binary search function that will be performing the binary search. So we can just first of all think about binary searching the row, and then we can think about eliminating the rows and searching for the apt row. That's what we can think about. So like if we start with like the binary search approach, so creating a function for the binary search, considering we have this single row left with us, so to perform binary search in this row, what do we need is we need a column start and a column end. We need the column mid. We need the row number, obviously, and we need the target element. So and we need to return it in the boolean way, so the boolean thing has to be there. So boolean uh, binary search. So boolean binary search, that will be taking our int row, int column start, int column end, uh, int column mid. Will that take column mid? I don't think so. I don't think so that it will be taking the column mid, because column mid we don't know. I mean, we know, but I guess we'll be performing that. Let's forget it for now. So we have the row, we have column start, we have column end, and then we can have int target. We need the row. So while we do binary search, while column start is less than equal to column end, while column start is less than equal to column end, what we can do is that we can have our int c mid for this. The column mid can be let's take it as only mid. We'll need, I guess, column mid in the further sections. Int mid will be column start plus column end minus column start by 2 if our so just a second, I forgot the main thing. Like we'll be needing the matrix, so we'll need to take the matrix right here, so that is important. So yeah, int matrix, we'll need this. So this equals to if our matrix our matrix row and mid are equal to target then we can return true. If else, we'll need the condition, my bad. If else, let's copy paste this. This is like less than target, then we can that's less than target, then we can make our the target is more than that, so target lies on the right hand side of it, so we can shift start. C start can be mid plus 1, else C end can be mid minus 1. Alright, so if the while loop doesn't work out, return false. Fair enough. So this is for the binary search. Now we'll be needing what do we say, search. We will need to eliminate certain rows. So for that, what we can do is we can take int search, wherein we will be taking this matrix into consideration, and after taking this matrix into consideration, what we can do is we can have the int target, because that is necessary. Now we will be working upon the case wherein either we have 0 rows, 0 column, or 1 row. So like for example, if we have 1 row, if let me here get this thing initialized. If int rows equal 1, alright, if int rows equals to 1, alright, no, how do I know it's only 1? It can be anything, so we need to assume that, not assume that, but take it as a row length, like matrix dot length. So this is basically the int rows, int column, that is matrix dot matrix 0 dot length. We have int r start, which will be as 0. We can have r end, so that will be as rows minus 1. We can also have r mid. Do we need r mid for the moment? I don't think so. We don't need r mid right now, because we will be having that in the while loop, because we will be needing to separate out other rows, so we don't need that r mid for the moment, but we will be needing the column mid. So int column int c mid can be column by 2. We can take the normal the actual convention as well, like here we took mid equals to c start plus c and everything, but it's fine. Here it's fine, because I don't for that I'll need to initialize everything, column and column start. So considering the constraints, if you see, so m and n, yeah, these values are like fair and fine enough, so no worries with these values, so this can be handled well. Alright, so if rows equal 1, then what we can do is we can return binary search, we can return binary search. That will be having our matrix, that will be having our row, like rows, like the number of it, like one row, like here we'll be needing that particular row, I would say. So yeah, that will be, I guess, yeah, 1. And then it will need a column start and a column end. So column start can be 0, column end can be col -1, and yeah, target, that will be passed, that will be returned. And if column equal 0, if column becomes 0, then it's formatted right. Yeah, if column becomes 0, then we can be like return false. So first of all, we took care of the binary search that we will be performing, and then we took care of the cases wherein we need to deal separately. Like we need to deal separately with if there is only one row, because then we don't need the whole search thing. We're eliminating the rows and finding out the apt rows and everything. If there is no column, then we dealt with it, that it's like not valid, so return false. Fair enough. Let's move forward. So now we will be needing to return the rows that we need. Like for example, here in this case we need to search for 5. So in order to search, so in order to search for 5, we don't need 6 the rows that start with 3, 10 and 18. So we don't need these 3 rows, we need these 2 rows, so we need to eliminate these. Alright, so what we can do is we can have a while loop. This while loop will be running till row start is not less than row end -1. So row end is basically rows -1, that is the length -1, that will be this one, and row end -1 will be this one, and the row end -1 is not included, so that will be till here only, from the row that starts from the element 3. So yeah, that's the thing that we'll be taking into consideration, which means that now we eliminated the rows. Alright, so yeah, it's fine. So we have this while loop. Alright, so int, now we will be having row mid, that will be r start plus r end minus r start by 2. Alright, so with this, if if our matrix r mid and c mid equal target, return the target simply. Return true. Alright, let's have if conditions only. If let's copy paste this. Alright, if this is the case, if this is more than the target, what we can do is if the armid and cmid have more than targets, the target lies above. So what we can do is we can have what can we have? So like 1, 2, 3, 4, 5. The mid will be at the 2. So yeah, r end can be equals to r mid. Alright, yeah, simple. And if this is the case, if this is the case, then what we can have is our start equals our mid. All right. So yeah, if it lies, the target is more than the thing, so we need to shift the r start so it becomes the r mid. So the thing is, here we are not doing the mid minus one thing and everything, because we have already taken that thing as n minus one, so we can't just go beyond that. We can't be like mid minus one, so that will be giving an error. So yeah, these are the conditions. And if this while loop, like when we come out of this while loop, all right, when we come out of this while loop, so now the thing is, not assuming, but this while loop will be giving us the rows that we actually need. All right. So when this while loop is giving us the rows that we actually need, so we need to only use those rows. All right. So when we have to use only those rows, then the simple thing is that considering that we will be having, all right, let's rar until this while loop for this condition. All right. So here we have this case. Binary search will be applied at the end, so that is just for the searching purposes. Main is the search function that we created. So here what we can see is that we have all this. So rows are not equal to 1, columns are not equal to 0. So let's perform this while loop. So now r start will be less than rn minus 1. So rn can be 0, 1, 2, 3, 4. All right, so 0, 1, 2, 3, 4. We have like 0 plus 4 divided by 2 gives us 2. 0, 1, 2. All right, so this will be the r mid. Yep, this will be the r mid. All right, what will be the r end? R end is basically right here. What we have is row minus 1. Rows is basically rows dot length, so that length is 5. Rows minus 1 is 4. R end is equal to 4. All right, so r end minus 1, r end minus 1 is basically 3. Yep, r end minus 1 is basically 3. So 0, 1, 2, 3. Yeah, I'm not covering this coming till here from the one that's starting with 3. So let's do it again. We have rows, r end is rows minus 1. So the r end value will be less than the rows. I mean, less than what the actual value of the length of the rows is. Reason being, zero indexing, starting from the zero index. So 0, 1, 2, 3, 4. So this will be 4 will be r end. All right. So here 4 will be r end. What we need is to go less than r end minus 1. R end minus 1 will be 3, not covering that. So this will be this. Fair enough. Completed. The logic is fine. So we will be covering only till the row that starts with 3. So only 0, 1 and 2. In general, 3 rows will be only covered starting from the top. All right. So now if we look at it, so we take out the row mid and the column mid. So row mid will be 0, 1, 2. That will be 1. So 0, 1. This will be the row middle. And what will be the column mid? Column mid is going to be, what do we have here? 0, 1, 2, 3, 4. So we have, what is column equals to matrix 0 dot length. All right. 1, 2, 3, 4, 5. So that will be giving us, divide by 2, 2. 0, 1, 2. This will be the column mid. Right. So this will be the element that we will be reaching upon. Column mid and the row mid, 8. Just in the right of the 5. So if we didn't get equal to target, so yeah, forget that case. Now we will be coming upon this case if the element is greater than the target. So yeah, that is greater than the target. So what we will be doing is we will be moving our end to our mid. So basically our mid is this only, so this becomes the R end. Fair enough. So now when this becomes the R end, then what do we need right now is to figure out like where the element is gonna lie. So now we have only these two rows left with us, all right, because our mid is equal to our end now, so our end become this, so we have these two rows only. So now what we need to do is that we need to figure out the cases, all right. So if this can be column mid, and out of 0 and 1, if we divide by 2, so this will be the row mid, all right. So considering that 7 is the middle element of both row mid and the thing, so 7 is the middle element. So now what we need to do is that we need to figure out the cases wherein it traverses, in this area, all right, in this area, vice versa. Like we need to cover these areas, and obviously we didn't get this as the answer, so yeah, we already know what to do. So now we need to cover the cases wherein that we compare the elements that are lying on the right hand side and on the left hand side of the our both rows and that columns, all right. So we need to do that. So like for that, what we can do is, after coming out of this while loop, now we have these two rows left with us, all right. So when we have these two rows left with us, then what we can do is that we can have if conditions, like for example if, all right. Now we will be performing the main binary search over here, all right. So when we have if condition right here, so how to check like what to do at this condition. So what we can do is that having this if loop with us, if condition with us, so what we can do is that first of all we can traverse in the direction, like suppose let's go on the right hand side, all right. So what do I have is I have r start, all right, and I have r start plus 1, because this was my r start as I took here. My r starts 0, my r start plus 1 becomes this, all right. So yeah, that's no problem. So what we can do is, if my matrix, let's figure out while we code. If matrix, first of all let's talk about the first row only. So our start, and we have here our column mid, all right, c mid. If r start and c mid, see if they would have been equal, all right, if they would have been equal, then we would have gotten the answer, but we didn't get the answer. That simply means that now we need to search in the whole row, because if r mid and c mid would have been equal, like the element would have been 8 at that moment, so we would have gotten the answer. But now what we need to do is we need to first of all search in the first row itself. So if r start and c mid, if the element if our we don't know if that's 5 or that's 4, so we need to search here, and here, all right. So 8 is covered, like 8 we did right there, that's not the target, so let's forget about that, all right. So we need to search for 11, 15, 12, 19, 1, 4 and 2, 5, well, like 1, 4 and 2, 5, all right. So if our r start is greater than or equal to, we don't know that, if our r start is greater than or equal to the target, all right, if that's the case, if r start and c mid, like if r start and c mid plus 1, my bad, no, but let's not keep it plus 1 right here, let's put that into the binary search value, all right. So if r start and c mid, that is gonna be 7, if that's greater or equal to target, like here in this case, if that's greater or equal to target, then what we need to do is that, see, if 7 is greater than the target, all right, if 7 is greater than the target, we need to search for 1 and 4, obviously, because 11 and 15 are greater than the element, but our target is smaller than the 7, so we need to search on the left hand side, all right. So like don't assume that the case answer is 5, it can be 1 and 4 as well, so we don't know that, all right. So if our target is less than the element that we have, so what we need to do is that we need to return binary binary search. So now we will be having our matrix. All right, we will be having our start. We will be having our column start, I guess. Column start, column end, and the target. We will be having our column start. Column start can be 0. We will be having our column end. Column end can be mid, C mid only. All right, and target is target. Yeah, return that. But if, all right, if our matrix, our start, let's copy this, control C, control V. If that's less than equal to, target, then what we can do is we can return binary search. What will that be doing? That will be taking the matrix into the consideration. That will be taking our r start as r start because we are in the same row only. All right. That will be taking what's that gonna what else is that gonna take? That will be taking our C start. Now the target is greater than the element. All right. So yeah, just a second. All right, my bad. Sorry. So now what the thing is that where will be? So we need an column start. So column start, now we need to find that out trickily. All right. What do I mean by that is we have our matrix, we have our r start. Now the target is greater than that. All right. So if the target is greater or equal to, we need to find that out, that now we can start from column mid only. See, these cases are to be taken care of because these cases might give out an error. All right, we don't know about that because we need to consider the column mid as well. Can't help it. All right, then we can have our column end as well. Wait, column end can be column -1. Yeah, and then we can have our target. So column end can be column -1. So yeah, and if matrix, we have that with us. Yeah, now we need to do a little bit change. We can here have +1, +1. So r start +1. So now we have the next row in consideration. C mid is gonna say the same. So if that's greater than or equal to target, we can have this whole thing as the same, just r start +1. All right. So yeah, yep, we can have a binary search matrix r start +1. We can have the column start from the 0. Yeah, and the case is gonna stay the same. All right. If this is the thing again. Yep. Now if that is less than equal to, yeah, target, what we can have is the less than equal to thing right over here with us. Control C, Control V. Yep. So return binary search matrix r start +1. Rest, let's keep everything the same. So we have these four conditions. Yeah, we have these four conditions wherein now what's happening is we had two rows. So first of all, we searched in the left hand side of the first row, and then we searched in the right hand side of the first row. Then we came down and then we searched into the left hand side of the second row, and then we searched in the right hand side of the second row. All right. So now what we can do is we can simply get out of here, but we need to return something. Alright, we're returning binary search, so it's fine. So now here what we can do is we can say boolean as the need answer in boolean answer equals to how we can call that search. We can have our matrix and we can have our target into it. Yeah, return answer. Yeah, let's run that. Let's see what happens. Alright, compile error. What's expected? If else if, my bad. Where? Yeah, I knew. If nothing works, return false. I didn't mean to submit that. So sorry. Yeah, wrong answer. Let's run that first of all. Let's run that. Alright, so case 1 it's not working, case 2 it's working. So let's figure out what's happening. Alright, so let's get the description. So for case 1 it's not working. Case 1 5 lies, but it's not working. So what it is giving out, it's giving out false. What if I return true? What if I return true? Alright, it's fine. So I guess the false coming from right over the binary search function. Alright, it's fine. What am I considering over here? Start, end, middle, and everything. Start. Alright, so 5 is lying in the second row. So let's figure out for the second row. Second row start C mid is greater than equal to target. So C mid is this. And that's greater or equal to target. Then what we can do is we can return binary search. Binary search will take matrix r start +1 as this row, and column start will be 0. Yeah. Column end will be mid, C mid. Yeah. Column end will be C mid. What is C mid? Column by 2. Column by 2 is C mid. Alright, so C mid is column by 2, so we can't be like C mid +1. Can we do that? So if that's the thing, let's see. If that works. Nope, it won't. It's less than that, so let's try right here. Wait. Yeah, target is less than that, so my bad. I was right before. the target is less than the C mid, so our start is from like that's fine. Column start is also fine. C mid is the C end. So C end is the C mid. C mid right over there is column by 2, that is 5 by 2, that is 2, 0, 1, 2, which is fair enough. Here we take out C mid. So 1, 2, 0, 1, 2. Column start 0. Column end 0, 1, 2, 2. The column mid will be 1. This will be the column mid. So if row and the mid are equal target, then return true. Why is it returning false? I mean, where is it wrong? If matrix row and mid are equal target, and it is considering till the end, it is getting like equal to C end, so yeah, it will be considering that. So it will say end mid C start, it will take out the end mid, so C start 0 plus C end, that is 0, 1, 2, 2 minus 0 by 2 is 1, so 0 plus 1 is 1, so 0, 1, this is, so if matrix row is given as R start plus 1, and the mid, that is what we took out right now, that is this right here, so this row and this element, if that's equal to target, then return true. So why it's saying false? Why is it saying false? Why is it saying false? It's working for this case. Yeah, they couldn't find 20, I guess. 20 wasn't in the, so yeah. See, I did the dry run, but still don't know. I still don't know why it's saying false. Let's see if we have any syntax errors. R start CML greater than target, so R start and C mid will be the ones. Here we have the R start plus 1, R start plus 1, R start plus 1, C mid, column minus 1, R start plus 1 till 0, like R start plus 1, column start 0, column and C mid. Target matrix. Let's see discussion. See, I can spend more time over this, but I don't want to, because nope, have to do more questions. I don't think so we'll find anything right over here. Nope. Return false, C mid, column 0, return false. Rows start from column 0, column minus 1, R start, R mid, then return true, C mid, R mid, C mid, R mid, C mid, R mid, C mid, R start, C mid, yeah. R start, C mid, R start plus 1, C mid, R start plus 1, C mid. What's the error? I can't understand why it's giving an error. Let's remove this. I can't understand what's the error, but I can't. Why giving an error for out of bounds single row case if rows 1, remember rows equal to row 1, binary search, zero indices are 0 based, passing row 1. No, but see, wait, what? I told that rows equal to matrix dot length. If the length is 1, then the indexing will be 0. How does that matter? Oops. What? Unreachable conditions in search. Edge case when target is not found. Your code is not are flawed because the second if and fourth if are redundant. Second if and fourth if. Second and the fourth. If matrix R start plus R start is greater than C mid, what? If matrix R start and C mid are greater than or equal to target, if matrix R start and C mid are greater than target, the second condition will be always true. Why? If R start and C mid are greater than the target, we will be searching in the left hand side. If R start and C mid are less than the target, we will be searching in the right hand side. So that has to be true, obviously. But what? So basically, they had C mid -1 in R start conditions, in like the positive conditions. I mean, when the left hand side has to be searched. Yeah, they had C mid -1. Here they had C mid -1, and here they had C mid -1. So basically, C end is C mid -1. Search between these two. So this won't be considered. But see, Alright, because I guess they're saying that you covered uh like, for example, right here, like I did cover, like, the second case I am covering the middle element. Alright, so basically it's like you need to cover the middle element only once. Maybe that thing is that what they're saying. Because I was what? Why? R star plus 1 C mid 0 C mid minus 1 C mid minus 1 when it is R start. So what they want. Alright, but okay, I understood what needs to be done. So if they're saying consider C mid only once, then that means that they don't want me to consider it over here as well. So yeah, I guess that's the fix. They don't want me to. Yep. So alright, so the basic learning is consider C mid only once. What? Index out of bound? Oh, minus 1 if matrix R start and C mid minus 1 is greater than equal to target. C mid minus 1. And uh, target is greater than equal to matrix R start and do we have something for column as 0? C mid minus 1. So if it's like C mid is 0, so we need we can use column. There's only no. We can use R start. What can be the column 0? So we can have so we can have, what can we have, like, just to make it like above it? I didn't know that this will be causing an error, but all right, so let's not get right here. Let's not, like, let's do one thing. We can consider the mid only once. What we can do is we can be like mid plus 1. Here we can be like mid plus 1. Here we can remove this. Yeah, we can remove this. Here also we can remove this. Here we can be like plus 1. Here also we can be like plus 1. Alright, but now we can have our conditions. And now target was greater, but the target has to be less than what? Matrix r start. Target has to be less than r start, and column less equal to, so column will be, see, the matrix dot length. Yeah, I guess that is gonna be column minus 1 because the last element has to be there. So target, yeah. How about now? Wrong answer. Wrong answer. Alright, it's fine. Alright. Let's see why. I said, like, I considered mid only once. Alright, here the mid is being considered. Here we are having mid plus 1. Alright, here mid is only considered. Here we are having mid plus 1. Yeah, mid plus 1 is right here. Let's have the same copy pasted right here. R start plus 1, column minus 1 is on target. How about now? Don't do that. I don't like it. C mid plus 1 is being considered. Column minus 1 is being considered. See, we are considering mid only once here. Only, here it is mid plus 1. Here we're considering mid, and here it is mid plus 1. We're making sure that it doesn't give index out of bound error, because so if it's like, if C mid plus 1, so it can be mid plus 1 a lot. So here the target is greater than that, so it can just like exceed the value. So we did that, like we made it like it has to be greater than equal to the target. Alright, it is going to be greater than equal to the target. So we can ask it C mid plus 1 and go till column minus 1. Alright, R start column minus 1. I don't see what's the error now. R start column minus 1 greater than target, column is the length minus column minus 1 target. We can spend all day searching for the error, and I won't be able to find it, because even if it's right in front of me, because I have written the whole code, and now I'm like, what? And I thought about errors. I fixed that. When accessing matrix C plus mid plus 1 start, in the mid plus 1 might be like, I know. Because column equals to 1. I know that. C mid plus 1. What if there's only one column? What to do then? I know. You need to fix add and ensure C mid plus 1 is within the column bounds. That C mid plus 1 is less than the column. Wait. How about now? I don't know. Redundant and flawed conditions, and so on. Unnecessarily complicated. This also means some cases outside the current. So how is that possible? How is that possible? Like I am traversing on the both sides. For example, matrix R plus doesn't ensure the target lies within the left half of the row. How does it not consider that? Like I am starting from R start as a zeroth row, zeroth column, going till C mid. How is it not like telling you that it is on the left hand side? Similarly, combining with seamless conditions might not cover all. Why? Wait. R start and C mid are greater than target. So I'm going from R start. So obviously I have to do that. It says 0. Target element is 8. Target element is 8. R start is 0. C mid is 2. That is 7. So if target element is 8, I'll go on the right hand side only. Right? It's not greater or equal to 8. It is less than that. Yeah, it is less than that. So we will be following this. If R start and C mid plus 1. Ooh. 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 But no. Wait, what? Wait. If matrix R start and C mid. If R start and C mid. Uh. If R start and C mid are greater than the target. Suppose if it's 8. No, they are not. Let's move to the next condition. C mid plus 1 are less than the target. Hmm. Hmm. True. Fair enough. All right. So we can follow this approach. It looks more clean, I would say. So let's start by doing this. All right. Did that do? All right. So what we can have right now is, let's put return true, control C, we do we need this? Let's see. Let it be there. So we'll perform binary search from our start. C start is 0, C mid will be covered. R start. Now we will be performing it from, yeah, obviously, like R start is the thing. We'll be going from column 0 is the column middle. We're going from the middle column to column -1. We'll be going from 0 till C middle. We'll be going from column middle mid +1 to column -1, and running true. So let's run this. Let's get rid of all the conditions. All right. What is the error? Oh, I can't be doing that. True. All right. Let's see. My bad. Wrong answer for case 2. Now case 1's fine. The case 2 is gonna give wrong answer. All right. Let's figure out why. That's all we need to do. Figuring out the errors for no reason. Let's try to mess with the conditions. Let's try to do that. Let's try to do that. Matrix R start 0, C mid -1, target. Matrix R start C mid column -1, target. All right. R start R start +1 C start mid -1, target. R start C mid, yeah, C mid column -1, target. Where is the issue? Where is it? I don't know how these questions take 1 hour. I know what binary search in 2D arrays. I don't know why it's gonna take 1 hour for it. Matrix R start, C mid, column -1, target. All right. Uh, let's. I would say let's. It's giving error for this case. Wait, what? I am thinking if 20 isn't even in the matrix, how is that gonna give me an error? Thank you. Thank you. What? 120 past of 130. Alright, let's have you as a test case as well. Let's see what you want. Target is 7. Do you lie? You do lie. Yeah, you lied twice. Congratulations. Wait, what? Can you repeat elements? Why? 2 is being repeated, 7 is repeated, 11 is repeated, 9 is repeated. I didn't know that. Elements can be repeated. Wait, so you want me to find 7? The output is coming false. Why? Why is it coming false? Expected it to be true. Alright, if you have more 7, that's fine. The output is coming out to be false. It's saying you don't have any 7. But you do have 7. Alright, now let's have a pen and paper dry run. Because I need to visualize this case. What do we have here? Is my audio working fine? I don't want 1 hour to be with no audio. It's fine. It's working fine. Yeah. 2, 5, 2, 8, 7, 9, 7, 11, 9, 11. How many rows? 1, 2, 3, 4, 5. 5 rows. Yeah. 2 column each. Yeah. So this is the thing we have. Let's make that as a box. Yep. So now the thing is, we need to search like for 7, right? So let's initialize it. We have 0 and 1 column, 0, 1, 2, 3 and 4. So let's start from the start, the search loop. Yeah, the search. We don't have this condition. Let's move ahead. While our start, our end is rows -1, so the last one. Then now we have to go from last one -1, not consider it, go till 0 and 1, 0, 1, 2, while that is the thing. So if our mid is obviously the second row, so if matrix mid and C mid will be 0 and 1 divided by 2 is equal to target, then return that is equal to target. Why is it not saying true? Why is the loop not stopping? Alright, so 2 columns, 4 rows, I mean, 2 columns, 5 rows, 0 to 4, 0 to 1. That's how it is. It says r mid is equal to r start plus r end minus r start by 2 to r. That's 2. That's 2. Second indexed row, 0, 1, 2. C mid. What is C mid? Column by 2. What's column? Column is that. So 1 by 2 is gonna give 0. So 0th is the C mid. So second row and 0th column. Second row and the 0th column gives R to be 7. Matrix R mid, C mid, equal target. Let's go. That's the answer. How is it giving an error? Matrix R mid. Do I have anything wrong? Like what? Oh. I don't want to see start. Goodness. Cannot find the symbol. Congratulations. Congratulations. Never take column by 2, never take row by 2, never do that. Wait, what? Anyways, never take column by 2, never take row by 2. Always take the condition that has to be taken. Let's use this test case. I'm like, you're gonna give me 10 errors? That's fine. Give me 10 errors. Because what do I have to do? One question the whole day? Yeah. Wrong answer, wrong answer. Matrix 14 false, true 14 lies. Alright, alright. Let's try run for you. But before that, let's figure out why. Why are you giving the wrong answer? What's the issue? Anyways, let's write it down. You have 5, 6, 10, 14, 6, 10, 13, 18, 10, 13, 18, 19. Let's make a box out of you. Yeah. Now let's look at the search thing. Alright. We have column, we have column start, we have column end, we have row start, we have row end, we have C mid, we have R mid further, we have everything now that we need. Perfectly initialized, right formulas used. What else? What's the issue then? So we start, alright, we say if row equal to 1, no, there are more than 1 rows. If column equals to 0, no, there are more than 0 columns. So let's move to the while thing. R start as an Rn minus 1. Let's initialize 0, 1, 2, 3, 0, 1, 2. So 3 rows, 4 columns, basically 0 to 2 rows and 0 to 3 to the columns. So why do these questions take more than 1 hour? I don't understand. Alright, so yeah. So now we start. We'll be going to row n minus 1. Yeah. So R mid will be R mid will be 0 to, that will be the first row, that is the second row, first index. Yep. So we'll search if matrix R mid and C mid is gonna be 1 itself. Alright, because 3 divided by 2 is 1. Yeah, 3 by 2 is 1, so 1. So that's gonna give us 10. If 10 is the target, nope, that's not the target. Let's move ahead. Is the 10 element greater than target? Nope, that's not the case. Is target greater than the element? Yeah, that is the case. Target is greater than the element. So what we do is R start becomes R mid. Wait, we have 10. No, but it's fine. So is 10 less than the target? Yeah, true, that is less than the target. So if R mid and C mid is less than the target, then R start becomes R mid. So yeah, now we have these two rows. We eliminated the 0th row, the 0th column, 0th indexed row. Now we have two rows starting from 6 and starting from 10. Yeah, so this thing is gone. Yeah, it's gone. So alright, so now what we do is, now we have two rows. We have to go till Rn minus 1. That is like, yeah, 0, 1, 2. Rn was this, Rn minus 1 was this. So yeah, it's fine. Now we have a binary search. Alright, so now so R start, so we have R start as 0, no, not R start as 0. So we have R start and we have 0, the binary search. So first, the second row will be taken. So R start and the column start is 0. It's gonna go till column mid minus 1. That will be 3 by 2, that's 1. If 3 by 2 is 1, that's gonna go till C mid minus 1. Oh, but that's gonna consider C mid as well. It's gonna go till C mid. We're gonna perform binary search over there. If that's equal to target, they're gonna return the target. Alright. Alright. The target is 14, but the 14th row is being eliminated. That's the issue. The first row that's eliminated, that contains 14. So alright, a lot to fix. The row that contains the target has been eliminated. I don't understand, why are they repeating numbers? Why are they doing that? So the row that contains 14 has been eliminated. The row that contains 14 is eliminated. How to stop that? Should I be performing binary search on each row? Like, will that not make code very much inefficient? Let's see a little bit discussion. Let's see that. I don't know this. The invariant clearly holds the beginning since the E is in the top right corner of the original matrix. If E is greater than the X and all images below E are larger than X, so this corner, went to in matrix and plus steps and expanding. Just give me the time complexity, just don't give me the history. Alright, so I'm working with this, and this is sorted matrix. This is sorted, completely sorted. The one I have is row and column sorted, so this makes no sense. Sorry to say. Alright. Cool. Cool stuff. Searching. Binary search. 2D, 40, 40, 2D, solid array, solid array. Search a 2D matrix. But it didn't give second one. Alright, I don't think so there exists a solution in binary search for this. Control A, Control C, Control V. Yeah, I know. If target is greater than R, mid and C start. Target is greater than R, mid and C start. And C end. Target is less than C end. R start is less than R end. So they didn't eliminate the rows. But then this code won't work for the other cases, you know. Like obviously. Within a row, if the target is within the bounds of that row, with overlapping values. For any targeting within the values that could be in the overlap region. So basically what they want me to do is, I have my search thing. I'll need to remove the elimination of rows and I'll have to perform a normal binary search, and the normal binary search will be from r start to r end. So int mid will be the same as it is r mid. If the target is greater than matrix r mid and c start, so what I need to do is that, and the target is less than r mid and c end. First of all, hold the r mid, c start, c end, then return that thing. But if target is less than that, else false. Alright. The target is less than matrix r mid. Return binary search. Starting from r mid, c start, c end, and target. So if target is greater than r mid and c start, and the target less than or equal to c start. Sorry, c end. Else if target is less than r mid and c start, then r end equals to r mid minus 1. Else r start equals to r mid minus 1. Alright, let's try that. We can try that. Alright. Control A. Control C. Where do I paste this? Let's paste it right here. Alright. What we can do is we can remove this whole thing in search. What we can do is just simply change this whilst r start, what was it, r start is less than equal to r end and r mid is the same if matrix r mid, what's the time of recording? And c start my bad. If matrix r mid and c start are greater or equal to target and matrix r mid and c end are less than equal to target, return binary search, return binary search, wherein you have your matrix, you have your r mid as the r start, you have c start, you have c end, you have target, else if what we can do is else if matrix r mid and start is greater than the target, then simply r mid middle and the c start, like the first column is greater than the target, then it won't be lying below it obviously. If r mid, the middle row, and the c start is basically a 0th column, so middle row 0th column, this element, if this element is greater than the target, then it obviously won't lie below, I would say, because obviously we need to search. So c end equals c mid minus 1, else c start equals c mid plus 1. Yeah, let's get rid of all this. Let's get rid of all this too. This is the while loop, this is the way the function ends. What do we want me to do? R start, target is less, so see target less, yep, R mid and c start, c mid minus 1, my bad, it's revolving around the r end, my bad, sorry, r r r r, the rows have to, alright, return false. Alright, let's get out of this while loop. The while loop, return false. How about now? Wrong answer, wrong answer, wrong answer, wrong answer, and wrong answer. Everywhere we see wrong answer. What's with this? C start C end by 2, matrix row mid target true, else if matrix row mid less than C end false, boolean int matrix target int rows int columns, if rows like that, if row 0 or all 0, return false. Can't find the symbol. What is calls? Call, return false. Return false. We have this wrong answer, wrong answer. Let's remove this. So we have that covered. R start is here 0, R end rows minus 1, C start 0, C end column minus 1, C end column minus 1, fair enough. While start is less than R end, R start R end, int mid R start R end minus R start by 2, if target is greater than Let me do the way they want me to do. If target is greater than or equal to matrix C start and everything, and if target is less than equal to matrix and everything, yeah. How about now? Matrix, wrong. Matrix R mid C start C end target, else if target is matrix R mid C start R mid C start, wrong answer, R end R mid -1, then matrix R mid and C start, else R start equals to R mid +1, return false. Yeah. This code won't be working for this. Analyzed everything. Even if you can't even run this because the first one is not working. So how many test cases passed with this? 114. How many were passed using mine? Uh, 120 people. Alright, let's end it right here. I don't know what to do with this question, a long recording, so bye bye.